Okay, so lab 3 covered biological molecules, solutions, and solubility. The main concept of this lab was pH and how acidic or basic certain solutions are. So pH is essentially a measure of how many of these H ions are out there. Conversely, it's a countermeasure. There's always an equal ratio of how many H ions are out there versus how many OH ions are out there. But you don't need to really worry about OH. It's just like the opposing force. So like in more basic solutions, you have more OH. But for our purposes, the more H ions you have, the more acidic, and thus the lower pH you have. And that's just how the math works. So more H ions, more acidic, lower pH. So strong acids are things that dissociate from their H immediately. So this is kind of an ionic bond right here with HCl. What happens when you put this in solution is that immediately the H dissociates and the chlorine dissociates too. This just goes off in solution, it's fine. But this, when you accumulate all these H's, they make everything very acidic and they're very reactive because they've got that good positive plus right there. And essentially, remember too, that the properties of water allow this. Remember where you have the H, the OH, there's that small negative, small positive, and that's why water will start binding up everything, including the H's with little bonds. So the main thing that we worked with was glutamate because we wanted to see if we could stop acidity from kind of overdoing everything. Let's see, 1, 2, 3. So, in solution with water, this is what glutamate looked like. And we did an experiment where we added glutamate, or MSG, I should say. Yeah, monosodium glutamate, sorry. Because this sodium over here it just heads off into nothing, basically. So with this solution right here, when we added the acid, the HCl, all of these hydrogen ions flooded the solution. But since MSG is a buffer, what it did is that it took up all of those H ions, all those acidic H ions, and it just bound them right here. So they were never allowed to be free in solution. It erased them essentially. In the solution where we didn't add MSG and we added water, it became really acidic. Okay. So the other thing we wanted to make sure of was that, given that water is able to bind up everything, we saw that water can eventually become hydrated. So, or like things can become fully saturated with water. And those shells of hydration that surround, say right here, say you put in salt into water, remember that, here, let's do this. Remember that the little oxygen molecules, they have that slight negative charge, so they kind of surround the sodium. On the other side, the H's in water, the hydrogens, they have more of that positive charge still because water is a polar molecule. That means it has two specific, it's unequal sharing. And that's why you have pluses here and the slight negative there. And so that means you can kind of have like shells of hydration around things. And that's why we see salt dissolve in water. We saw the same thing with sucrose, and we saw that although sucrose can be in a shell of hydration, it doesn't disassociate the way ionic bonds do. And that's because NaCl, these are two pretty much separate things that are being kept together by their charge, but in water, they're more spread out. And the water can actually associate with them better. Sucrose is covalent bonded, so I can't remember its full structure, but it's like got some like rings and stuff. So it's not gonna break apart like these carbon rings or anything. It'll still get the water to like surround it though. And we saw that despite saturating with sucrose, despite saturating it, you can still bind up like another new molecule too. We also saw that with fatty acids, so these are super hydrophobic. So when water's around them, it essentially repels them. And that's why you see kind of fat globules whenever you spill cooking oil or something into water. It's because they kind of form little like collections of themselves because they only want to associate together. These fatty acid tails, they only want to associate together. They don't want to associate with water.
Yep.